Okay, so today we're going to be going over open and closed systems. Now, an open and closed system is the idea that can the numbers create something that is higher on the hierarchy of numbers. So an open system, I take a whole number and a whole number and it creates an integer through the operation subtraction. So whole numbers do not have within them integers. Integers have whole numbers, so I have taken two things and made something higher or more complex. Unlikewise, with a closed system, I have a whole number and a whole number. I make a whole number. Or you could say I have a natural, and I make a natural. Nothing new is made here. It's more of the same. So that's in essence what we're going through here. So some abstract examples for those of you who still need to wrap your mind around what is going on here are some of these going on. We have a male duck and a female duck produce should be duckling, but we're going to go with that. So we have a male duck and a female duck produce a duckling. So is this duckling different than what came before it? Well, we know through evolution it's a little bit different. It might be a little bigger, a little faster, a little stronger, but overall it's going to be a duck. So this is going to be a closed system. Let's actually do this in a different color. Let's do this in red. So we have a closed system. Nothing about this duck is different than those ducks. If I take a look at number 3, a Russian mother and a Russian father produce a child. Well, is there a way that that child is not going to eventually become a Russian mother and a Russian father? Well, there is a chance. Let's say the Russian mother and the Russian father have the child on American soil. Well, if it's produced on American soil, the United States does offer the possibility for citizenship for any persons born on its soil. So that child could grow up to become an American mother, an American father, not necessarily Russian. It could choose to keep its Russian citizenship, but there is a chance that we would produce something that is not included in its already given subset. So this would be an open system because we've produced something not like the original two. The child is born on American soil. Perfect. So the child is born on American soil. If you can read that, it'll be a little neater in the future. Let's jump over to number 5. Number 5 is a mother and father born with albinism produce a child. Okay? Well, is there a chance that that child is something different than a mother and father with albinism? Well, the answer to this is no. This is a closed system. Because with albinism, we know that that is a recessive trait, which means the mother and the father. Let's say if we have the genes A, which is non-albinism, does not conclude albinism, and then little a, which does. We know that in order for the mother and father to have albinism, they both have to have the genes. This is the mom, and this is the dad. And so no matter what combination of their genes, the child is going to have both of those albino-producing genes, which means the child is going to be a child with albinism. So, some ideas that we have right here. These are the concepts of what we're doing with numbers. And so, for the next type of problems, let's take a look at these right here so that we can fill in our table down here at the bottom. Now, the table is our main goal. We want to see, are these different categories open or closed through these operations? And I've given a few examples up here to kind of give you a clue into that. So for number 7, we have what looks like a natural number and a natural number through addition. This will give us 12, which is a natural number. Nothing new is created here. Actually, let's zoom in a little bit so that we can, because we'll go back down to the table here in a moment. So we have a natural number and a natural number produce the number 12, which is also itself a natural number. So can we think of 2 other natural numbers that when we add them together produce something that is not natural? Well, no matter how long we think, no 2 natural numbers when added will give me 12. You might say, well, how about 0? Because 0 has that, but remember 0 is considered a whole number. That's not included in the natural number set. No matter what numbers I add, all the way up, so on and so forth, I can't get anything other than just a bigger natural number. So we know that down here with the table, our natural numbers are closed through addition. So we're just going to go ahead and we're going to shade this in. There's no way that we can produce anything outside of that. Now, conversely, if I were to take that and say, okay, what about through subtraction? Well, I could say 5 minus 7. 5 is a natural number. 7 is a natural number. And I get a -2, which is an integer. That means that this is open. So this is going to be my example of how this system is open. Where this one was closed, there's no example. I move through and I say multiplication. Well, I could say 5 times 7. That'd give me 35. And with multiplication, remember multiplication is a variation of addition. No matter what two natural numbers I multiply, I'm just going to get a really big natural number. So multiplication likewise is closed. I can't create anything new. Okay? But natural numbers through division, well, I could take 5 and I could say divided by 7. This is a natural number. This is a natural number, and I will get 5/7, which is a rational. So this one is open. I can take two natural numbers through the operation of division and produce a rational number, something that is a higher type of number. So that's the goal of what we're doing right here, is we want to be able to fill out this table and either say nothing new is created or new things are created. So let's go through and see if we can't fill in a few more with our examples. So with number 9, I have, let's see, -4. This is an integer, and this is an integer. When I multiply them together, I get 20, which is a natural number. It's something different, but is it something new? Well, the answer is no, because natural numbers are included in integers. Remember, integers are whole numbers, which are natural numbers. So in essence, I already have natural numbers in this thing. I can't create something new because they've already got that as part of their description. So can we think of two negative numbers that when multiplied together give me something that isn't a natural number or an integer as well? And the answer is no. No matter what I'm going to do, it's going to create one of these. I could multiply zeros together, but I get a whole number, which is already included. I could do positive numbers, which would give me positive. That'd already be included. I could do a natural times an integer, but again, that would mean that I'm doing integers, but no examples is going to give me something new. So when I go down to integers, in the subset of multiplication, I'm going to say that this is closed. Can't think of anything that would make that work. But if I wanted to do division, I could take that -4 and divide it by -5. This is an integer. This is an integer. And I would get 4/5. This is a rational number, meaning this is open. Perfect. And so we kind of see what we're going through here. Up here at number 11, I have 18, which is a natural, and I have 3, which is a natural. Through the art of division, we produce a natural number. And so through division, we've already said that yes, there are examples that we can come up with that open up the system, but this example would indicate that this should be closed. So actually, if we went through and we did actually say this, natural number plus natural number, this is closed. We said integer times integer, this is closed. We know that this, albeit this particular example is closed, we know this is open because I could say, how about 17, which is natural, divided by 3, which is natural, which would give me 17/3, which is rational. Perfect, so this is open if I change up one of those numbers. They're still both natural, but I get something different. Awesome. And so why don't you go ahead and you try finishing out the rest of this table. just going through any of the ones and seeing, does it create something new? Or am I unable to create something new? And if you're unable to create something new, just go ahead and shade that in. And there you go. That is the open and closed systems.